thinking about starting. How do I tell you that deployments suck? Everyone's experienced a bad deployment. The most recent one I had was there was some configuration missing, and this wasn't immediately obvious. So we went through the deployment process. Fortunately, in this particular arm, it only takes 10 minutes to do a deployment. So we waited patiently for 10 minutes, watching the logs, tick, tick, tick. Everything's got into ECS. AWS logs are all reporting fine. And then the app started, and then it stopped. And then it started on a different container, and then it stopped. I'm like, oh no, this is going bad. Something's gone wrong with the deployment. Quickly go to the live page. Thankfully, everything on the live page is still working. The new deployment hasn't taken any effect or taken any live traffic yet. And then eventually, the deployment software says, yeah, this is not starting, I'm going to give up. So it squished that, and the live traffic was never affected. This is great. And this is because I use all of my experience to make sure that that doesn't happen. A failed deployment should not be noticeable to the users, only to the engineers and the people doing the deployment. So here's my 5 tips so that you can avoid deployments that suck. Tip 1. Automated testing. In every deployment I do, here's a picture for you. There's a set stage that goes through the deployment processes. The first and most important stage of that thing is the automated tests. Once we've built whatever we're deploying, we want to ensure that it conforms to the tests that we've also written, the contracts that we've got, the expectation that the app will do stuff in a certain way. So the automated tests come along, and they should run as quickly as possible, under 2 minutes. It builds the thing, and then it runs the tests. The most recent project I've been working on has got over 150 tests, and it takes just over 2 minutes to run. And all those tests, when they come back green, we know that there's nothing particularly wrong with our code. But it's great. So we're ready to try a deployment. Now there's some things you can do, and there's some things that you might fail to do when talking about automated deployments. There's a thing called code coverage. Now ideally, everything would be 100% code covered. Code coverage is a way of telling us that our tests have executed every single line of code that we've written. Now, some of those lines of code aren't particularly important. Let's imagine that there is an edge case that, now there's some things you can do, and there's some things that you might fail to do when talking about automated deployments. There's a thing called code coverage. Now, ideally, everything would be 100% code covered. Code coverage is a way of telling us that our tests have executed every single line of code that we've written. Now, some of those lines of code aren't particularly important. Let's imagine that there is an edge case that when an exception is thrown, another exception is thrown, and then it outputs a log message. Now, it might take us ages to mock the responses for that. It might be such an out there content that we don't even think it's ever going to happen. So you might skip the test for that. Now, this is a risk. Yes, you're not going to get 100% coverage, which is probably okay. On the other hand, as soon as you do a deployment and that thing does happen, that's when you really wanted the test to be there. So you could leave the test for now, depends on how much effort it's going to take to create the test. Of course, if you're following true test-driven development, you already write the test before you even start writing the code. Tip 2. Feature flags. Great. What the heck is a feature flag? Well, a feature flag is where a certain piece of code sits there dormant and it does nothing, unless there's another piece of configuration that says, "Hi, switch yourself on, let's run this piece of code." This is useful when you're developing a new feature in your code so that it doesn't take any effect whatsoever in a live environment unless you want it to, unless some certain conditions are met. Those conditions might be, we want to roll it out only to power users. Only our users that have signed up for extra beta testing. So the code can exist in the live deployment, but it only runs when the configuration is set, such as the user that's currently logged in is part of our public live testing group. Or you can set it on other flags. So another deployment I was doing where we had feature flags and they would be switched on for one of the integration environments. We had 3 integration environments at that time. And so whichever one I was working in, we could deploy our code. It would go through all of the pipeline. The code would be deployed to all 3 of the feature environments and pre-prod and production. But it wouldn't be switched on in any of those apart from the one integration environment that we were testing in. And therefore we knew that it wasn't going to affect production code. And if we did want to switch it on production, it was a configuration change just to switch it on and not a whole new redeployment. So this reduces your risk by the fact that the code won't actually run until you want it to. This means it can lie in code dormant for ages and ages whilst you're building out the rest of the thing. This is very useful for large pieces of code that need several moving parts in order to work correctly. It might rely on other bits working. It might rely on a different database schema. It might rely on a new component that's not even written yet. And so you can incrementally deploy all of these changes, knowing that you can run your automated tests like we did in the last tip and deploy it out to production so that we know the code is there and deployment works end to end and we've got no issues. And so we're not introducing any bugs at that time. We can get rid of them really quickly whilst we continue to build out the rest of the feature, which might take more than 2, 3, 4 deployments in order to get that fully deployed. Tip number 3, blue-green deployments. So here's a picture of a blue-green deployment. You might think that you're seeing double, and you'd be right. With a blue-green deployment, you've essentially got double everything. Double load balancers, double compute nodes, double databases, everything is duplicated. And so with a blue-green deployment, you fully deploy. So normally the parlance is blue is what's currently live. So all the live traffic is hitting blue, whatever that is, over here. And you've got your green infrastructure and it's sitting there idle. So you do a deployment to the green infrastructure. You've done your automated tests, so you know your tests work. You're now doing a deployment, and now you can throw some test traffic at it. Entirely up to you what tests you run on that. At one organization, we did this in order to test database schema changes, because they're really difficult to roll back. Anything to do with database and rolling back is tricky. So building out a completely separate infrastructure with the code, the version that needs that database, and the database schema, and some data, some synthetic data, so that we can test that things actually work properly. And with it all sitting there, we know that live, like in my earlier example, live is completely happy. It's running on the blue infrastructure, and it's just serving stuff as it always has done. The green infrastructure is sitting there with our new code, our new database, our new schema, and we're throwing some tests at it. We're throwing integration tests at it. Can it talk to this? Can it talk to that? It is essentially in production already, so it can access everything it can. The only difference is it's different load balancer, different compute, different database, and therefore it's running a different version of the code, but that code is only working on that version of that database. So it's separate to our live database. Once we're then happy with that, we can then flick a switch, usually a DNS entry, so that the DNS pops from the blue over to the green. And now something weird happens. The green is now technically blue, and the blue can now be torn down and thrown away. You might want to run the live environment in live for a little while before you tear down the old one. That's entirely up to your testing processes. But once it's there, the advantage of a blue-green is if then when you start switching live traffic over, oh my God, it all goes wrong, you can flip the switch back to green again. And off of green into blue, and you know that everything's essentially rolled back instantly. In an instant, you've got to roll back. So it's quite a safe way to do things. It's quite a safe way of running things. The downsides, of course, is it's going to cost you twice as much money to run because you've got double everything. It's all duplicated. And if you do run into that scenario where you've got your blue, you've switched over to green, any data that you're capturing now in green will only hit the new database. So there's two things you need to do. Before you flip the switch, you need to make sure that those databases are synced so you don't lose any data. Likewise, if you do choose to flick back, any new data in the green needs to be replicated back into blue, or you have to accept that data loss in between. So, like I said, working with data is tricky, and there are things you have to watch out for. So keeping the data safe is one of those. Tip 4, monitoring. When I'm monitoring a deployment, there's some essential statistics that I want to keep my eye on. The main indicator, if you're developing a web application, is going to be the errors that are coming in. The status codes when something hits the website. Now, usually it's a 200 or a 201 or a 204 or something, a nice 200 code. This means everything went well from the server's expectation and the client's expectation. What you want to check for is if you get any 4 errors. So if all the 400 codes mean that the customer sent some data that the server didn't understand. Like a 404, you asked for a page that didn't exist. Or a 401, you don't have permission to hit that page. Now, of course, some of these can be affected by our deployment. If we've accidentally deleted a page during our code update, then all of a sudden, people are getting 404s because they're hitting that page that we didn't think they needed anymore. You quickly roll back. There's also 500 errors. Now, 500 errors means that something on the server side went wonky. These can be caused by something like the server code crashing and throwing an exception, or a database schema being different to what you think it is, which tends to cause an exception. Either way, it's a code exception. So the monitoring of those metrics is the result of the page code in HTTP, seeing whether it's a 200, a 400, or a 500, and quickly gauge whether your deployment was working or not. The other metrics I tend to watch for is CPU, but then that's subjective. You want a baseline of what your CPU is normally, and then a baseline taken after the deployment so you can see what your new code does. Does it use more CPU? In which case you might have to increase some of your other metrics when you scale. Does it use less CPU? Likewise, you might have to tweak those auto-scaling statistics. And then there's disk. That's the other bottleneck that I like to watch out for, is how much disk is being used, particularly with databases. If you're looking for speed, then your 200 code will say everything went fine. You might want to check out what the reaction speed, what the response time was of the web page. And if that drastically grows, then you'll need to debug further down. And it's usually disk or database that's causing that lag in your statistics. So it's a little bit more detail to see where that issue is. And remember, if you're running a blue-green, you can do this very quickly on the green environment before you flick the switch. And likewise afterwards, and if anything does go awry, you can switch back again. So in order to help spot these errors, let's put some alerts in place. These alerts should be there all the time anyway, just because stuff goes wrong, you should be ready for that. Now, alerts on if 10% of the traffic is resulting in a 400 or a 500 error, then we want to wake somebody up to say something's going seriously wrong. 10% of our traffic is experiencing a problem. Let's fix it now. Likewise, disk space can also be a killer if you're watching that. Running out of disk space is the quickest way to kill any server. So with those couple of alerts set up, not only can we watch the logs as the deployment happening, we can also have the alerts coming in so that we can get alerted immediately if something's going away from our happy path. Tip number 5, rollbacks. Now some of you might be running in a cab environment. This is the change board. They will ask you straight away, if a deployment goes wrong, what's your recovery action? Now, normally if you're using feature requests and stuff, like I mentioned in tip 2, then stuff can go forwards and you can fix forwards. You don't necessarily need to roll back. But if you're using blue-green deployments, then rolling back is built into the blue-green deployment. Easy peasy. And so you can have an automated script. Like in my intro, I mentioned it was watching for errors. The application didn't start. This means we would have got 503s on the load balancer because nothing was there to respond to the request. And after so many of those, the automation script said, okay, we've tried for 2 minutes, still nothing's happening, so we're going to roll back and back out. And because it was combined with a blue-green, the live traffic was never touched, and it was only the green that had to be rolled back. So in actuality, it just got deleted. And so nothing was spoken of it ever again, apart from amongst the devs and the engineers meeting to say, well, what went wrong with that deployment? Let's do it better next time. And so it's important to gather the statistics, the metrics, and all of the logs if possible. One of the advantages of having everything duplicated is that the logs should also be duplicated. And so you can look at those in order to determine what did go wrong. And having a rollback in place means you know exactly what you're going to do when it does go wrong. It also means that the recovery time is very much shorter than it would otherwise be. In fact, recovery time is one of the DORA metrics that I spoke about in my previous video. If you don't know what I'm talking about, here's a link in the description for the previous video about the DORA statistics and metrics. So that's all I have for you today. And any questions, hit me up on the Tech Answers group. And I hope that in the future, all your deployments go smooth. Neil out.